Good morning, students. Today we can continue the complex numbers topic problems. Now, 31st problem. Here given argument of z less than 0 means argument of z is negative value. Required argument of minus z minus argument of z. Now, argument of minus z. Here argument of z less than 0, negative value. Therefore, argument of minus z. First argument of minus z equals to pi plus theta, where theta is, let argument of z equals to theta. Z equals to theta. Now, argument of minus z equals to pi plus theta, because here theta less than 0 given argument. If suppose only argument of z is theta, if it is positive, pi minus theta. Therefore, here required value argument of minus z, required argument of minus z minus argument of z. Now, argument of minus z equals to pi plus theta minus argument of z is theta. Minus theta plus theta get cancel, pi equals to pi. Now, option is first option. Next, if here given condition mod of z1 plus z2 equals to mod of z1 minus z2, then the difference between arguments of z1 and z2 means required argument of z1 minus argument of z2, Now, first here consider z1 equals to r1 of cos theta 1 plus I sin theta 1, polar form. Means here r1 nothing but modulus of z1, theta 1 is argument of z1. Next, z2 equals to consider r2 into cos theta 1, theta 2 take it, plus I sin theta 2, Okay. Now, z1 plus z2 equals to r1 cos theta 1 plus r2 cos theta 2 plus r1 I sin theta 1, r2 I sin theta 2. Now, I take common, we get r1 sin theta 1 plus r2 sin theta 2. Now, required mod of z1 plus z2. Mod of z1 plus z2 equals to square root of real part square plus imaginary part square. r1 cos theta 1 plus r2 cos theta 2 whole square plus r1 sin theta 1 plus r2 sin theta 2 whole square. Now, that equals to square root of r1 cos theta, r1 square cos theta 1 square plus r2 square cos square theta 2 plus 2 r1 r2 cos theta 1 cos theta 2 plus similarly r1 square sin square theta 1 plus r2 square sin square theta 2 plus 2 r1 r2 2 r1 r2 sin theta 1 sin theta 2 sin theta 2. Now here r1 square cos square theta 1 plus r1 square sin square theta 1, that equals to we get square root of r1 square. Similarly r2 square cos square theta 2 plus r2 square sin square theta 2. Now r2 square take common, cos square theta 2 plus sin square theta 2 1 r2 square. Next in remaining two terms 2 r1 r2 take common, we get cos theta 1 cos theta 2 plus sin theta 1 sin theta 2, that is nothing but cos of theta 1 minus theta 2, cos of theta 1 minus theta 2. Similarly we get z1 minus z2, mod of z1 minus z2 equals to square root of r1 square plus r2 square minus 2 r1 r2 cos of theta 1 minus theta 2, cos of theta 1 minus theta 2 we get. Okay. Now here mod of z1 plus z2 equals to mod of z1 minus z2 given. Now squaring on both sides, mod of z1 plus z2 whole square equals to mod of z1 minus z2 whole square. But mod of z1 plus z2 equals to this value mod of z1 minus z2. Now both are equal, that equals to r1 square plus r2 square plus 2 r1 r2 cos of theta 1 minus theta 2 equals to mod of z1 minus z2 whole square equals to r1 square plus r2 square minus 2 r1 r2 cos of theta 1 minus theta 2. Now r1 square cancel, r2 square cancel, complete take left side, we get 4 r1 r2 cos of theta 1 minus theta 2 equals to 0, complete take left side. Now it is also a complex number, here its modulus equals to 4 r1 r2 and amplitude equals to theta 1 minus theta 2. Now theta 1 minus theta 2 equals to 90, because cos theta equals to 0, theta equals to 90 degrees. Now theta 1 nothing but argument of z1 minus theta 2 argument of z2, that equals to 90 degrees. Pi by 2 is the answer. Now answer pi by 2. Then option B is correct. Second option. Next, z equals to, here given z equals to 1 plus I root 3 whole square by 4i into 1 minus I root 3. Then mod z, modulus of z and argument of z both are required. Now here given z equals to given 1 plus I root 3 whole square, a plus b whole square, expand 1 plus I square into 3 minus plus 2i root 3 by denominator 4i of 1 minus I root 3, that equals to, here I square equals to minus 1, 1 minus 3 minus 2 plus 2i root 3 by 4i of 1 minus root 3 I root 3. In numerator minus 2 take common, minus 2 of 1 minus I root 3 by 4i of 1 minus I root 3. Now 1 minus root 3 get cancel, 2 times cancel. Therefore z equals to minus 1 by 2i, minus 1 by 2i. Now it is multiplied and divided by I. We get minus I by 2I square. But I square equals to minus 1. Minus minus get cancelled. That equals to half into I. Half into I. Or 0 plus 1 by 2 of I. It is given complex number Z. Here given Z equals to, given complex number Z equals to 0 plus 1 by 2 I. Now first mod of Z equals to square root of real part square plus imaginary part square. 0 plus 1 by 2 whole square. That equals to 1 by 2. Square root of 1 by 4 or 1 by 2. Modulus equals to 1 by 2. Next to argument of Z. Argument of Z equals to tan inverse y by x, or that equals to tan inverse 1 by 2 by 0, or tan inverse infinite, that equals to pi by 2, because tan pi by 2 infinite. Now modulus or absolute value is 1 by 2 and argument is pi by 2. Now second option is correct. Next problem. For n an integer, the argument of z equals to root 3 plus I whole to the power of 4n plus 1 by 1 minus I root 3 whole to the power of 4n. Required argument of z. Argument of z. Now here z, it is multiplied and divided by 2, root 3 by 2 plus I by 2 whole to the power of 4n plus 1. In denominator also multiplied and divide with 2. 1 by 2 minus I root 3 by 2 whole to the power of 4n. That equals to here 2 to the power of 4n plus 1, 4n plus 1 into root 3 by 2 equals to cos pi by 6 plus 1 by 2 equals to sin pi by 6, means I into sin pi by 6 whole to the power of 4n plus 1 by, in denominator 2 to the power of 4n into 1 by 2 equals to cos minus pi by 3, cos pi by 3 or cos minus pi by 3, minus root 3 by 2 equals to I into sin minus pi by 3 whole to the power of 4n. Now 2 to the power of 4n get cancelled, numerator we get only 2, that equals to 2 into, here you know Euler's formula, cos theta plus I sin theta equals to, cos theta plus I sin theta equals to e power I theta, e power I theta. Now that equals to e to the power of I pi by 6 whole to the power of 4n plus 1 by e to the power of I theta minus I pi by 3 whole to the power of 4n, whole to the power of 4n. Now that equals to 2 into e to the power of, how much you get, I into 4n plus 1 into pi by 6, it is take as numerator, we get plus I into 4n pi by 3, 4n pi by 3. Now that equals to 2 into e to the power of, I take common. Now that equals to 4n pi by 6 plus pi by 6 plus 4n pi by 3, 4n pi by 3. here pi by 6 multiplied. Now that equals to 2 into e to the power of I into, for these two terms take LCM. What is LCM? 6 LCM. We get 4n pi plus 8n pi plus pi by 6. That equals to 2 into e to the power of I 12n pi by 6, or that equals to 2n pi plus pi by 6 plus pi by 6. Now again this write in terms of theta, that equals to 2 into cos 2n pi plus pi by 6 plus I sin 2n pi plus pi by 6. Now that equals to 2 into 2 of cos pi by 6 plus I sin pi by 6, sin pi by 6. Now here theta equals to pi by 6. Therefore amplitude of the complex number or argument of z, therefore argument of z equals to pi by 6, pi by 6. Now option is first option. Next, the mod amplitude form of the complex number minus 4i, minus 4i. What is the mod amplitude form? R into cos theta plus I sin theta, cos theta plus I sin theta, or convert in this form, or it also can be written as R into cis theta, R into cis theta, convert it. That equals to, here minus 4i equals to 4 of minus I, 4 of minus I, that equals to 4 of 0 plus I into minus 1, minus I can be written as I into minus 1, that equals to 4 of cos minus pi by 2 plus I into, because cos pi by 2 equals to 90, cos 90 equals to 0, cos minus theta equals to cos theta only, that equals to 0 can be written as cos minus pi by 2, I into minus 1 equals to sin minus pi by 2, sin minus pi by 2, that equals to 4 into cis minus pi by 2. Now it is mod amplitude form of the given complex number 4i. Now option is 4, 4 into cis minus pi by 2. Next, sixth problem, the principal mod amplitude form of 2 minus root 3 plus I, 2 minus root 3 into I. Now what is the mod amplitude form? R into cis theta, where what is the value of R? R is modulus, modulus equals to R equals to square root of x square plus y square, real part square plus imaginary part whole square. Now here x equals to 2 minus root 3 or real part, imaginary part equals to here 1, 1 into I, y equals to 1. Now what is R equals to square root of x square 2 minus root 3 whole square plus 1 square, that equals to square root of 4 plus root 3 whole square 3 minus 2ab, minus 2 into minus root 3, that equals to minus 4 root 3 plus 1, that equals to square root of 8 minus 4 root 3. 4 root 3 can be written as 2 into remaining 2 take inside of the square root, that equals to 12, equals to 12, that equals to square root of 8 can be written as 6 plus 2 minus 2 into root 2 value equals to 6 into 2, 6 into 2, or that equals to square root of root 6 whole square minus root 2 whole square, plus minus 2 into root 6 into root 2, or that equals to, it is in the form of a square plus b square minus 2ab, square root of root 6 minus root 2 whole square, that equals to root 6 minus root 2. Therefore, r equals to modulus r equals to root 6 minus root 2. Next, required theta. Theta equals to tan inverse y by x, or that equals to tan inverse, here y nothing but 1 by 2 minus root 3, that equals to tan inverse, here rationalize the denominator 2 plus root 3 by 4 minus 3 1, tan inverse 2 plus root 3, but it is nothing but 75 degrees, that equals to 5 pi by 12 radians, Therefore, mod amplitude form of the complex number r into cis theta, that equals to, here what is r equals to root 6 minus root 2 into cis theta equals to 5 pi by 12. Now, it is the required answer. Now, option is first option, root 6 minus root 2 cis 5 pi by 12. Next, seventh problem. The value of log 1 plus I by 1 minus I by 1 plus I equals to, now that equals to log of 1 minus I by 1 plus I, it is multiplied and divided by 1 minus I, multiplied and divided, or conjugate of denominator, that equals to, we get log of numerator 1 minus I into 1 minus I, whole square, a minus b whole square, 1 plus I square minus 2I, by denominator a plus b into a minus b, a square minus b square, 1 square minus I square, or that equals to log of 1 I square equals to minus 1 minus 2I by denominator 1 plus 1, minus 1 plus 1 cancel, that equals to log of minus 2I by 2, 2 to get cancel, that equals to log of minus I, log of minus I. Now, that equals to log of minus I can be written as 0 plus minus 1 into I, or I into minus 1, that equals to log 0 equals to cos minus pi by 2, cos 90 value 0, plus I into minus 1 equals to sin minus pi by 2, or that equals to log of e to the power of minus I pi by 2, Euler's formula with base e, that equals to minus I pi by 2 log e base e, but log e base e equals to 1. Now, answer is minus I pi by 2, Then, option C is correct, minus I pi by 2. Next, eighth problem. If m is negative, m less than 0, negative value, the real number negative and real number log mi equals to, required the value of log mi. Now, here let m equals to minus n, where n is positive, because m is negative, n positive minus n negative. Okay. Now that equals to log of minus ni that equals to log n into minus I. It can be written as log m into n equals to log m plus log n, that equals to log n plus log minus I, that equals to, here what is the value of log n? N equals to minus m. Now log of minus m plus log I equals to, in previous problem, minus I pi by 2, Therefore answer is log of minus m minus I pi by 2. Log of minus m minus I pi by 2. Option C is correct. Option C. Next, 9th problem. The complex numbers Z1, Z2 and Z3 satisfies the vertices of the triangle. Now given here Z1 minus Z3 by Z2 minus Z3, that equals to 1 minus I root 3 by 2. Here actually, see, mod of Z1 minus Z2 equals to distance between the 2 points Z1 and Z2, because see it, let Z1 equals to x1 plus I by 1, let Z2 equals to x2 plus I by 2, Now what is Z1 minus Z2 equals to? From subtract x1 minus x2 plus I into y1 minus y2, Z1 minus Z2. Now mod of Z1 minus Z2 equals to square root of x1 minus x2 whole square plus y1 minus y2 whole square. Now it is nothing but a distance between 2 points in 2D geometry, distance between 2 points. Now mod of Z1 minus Z2 nothing but it is a distance between Z1 and Z2. Now both sides take modulus for given complex number. Now mod of Z1 minus Z3 by mod of Z2 minus Z3 equals to, what is modulus of numerator? 1 plus root 3 whole square, 3 by 2, that equals to 2 by 2 or 1. Therefore here mod of Z1 minus Z3 equals to mod of Z2 minus Z3. Now both are equal. If suppose triangle, it is considered Z1, Z2, Z3. Z1 minus Z3, nothing but the distance between these 2 points. Mod of Z2 minus Z3, these 2 values, both are equal. 2 sides equal. Next, if suppose third side is also equals to these 2 sides, equilateral. If third side not equals to these 2 sides, isosceles. Now see it. Here given complex number Z1 minus Z3 equals to 1 minus I root 3 by 2, 1 minus I root 3 by 2 into Z2 minus Z3. Now Z1 minus Z3 equals to 1 by 2 minus I root 3 by 2. It is nothing but 1 by 2 minus I root 3 by 2 equals to 1 by 2 cos pi by 3, or take minus sign, because cos minus theta equals to minus cos theta, plus I into sin minus pi by 3, or that equals to e to the power of I into minus pi by 3. Now it is equals to Z1 minus Z3 equals to Z2 minus Z3 into e to the power of minus I pi by 3, means angle between these two equals to 60 degrees, pi by 3. Now these two sides are equal, base angles also equal in isosceles triangle. Now pi by 3 nothing but it is 60 degrees. Therefore these two also 60 degrees each. All three angles are equal. Therefore the triangle is equilateral. Option C is correct. Next, ABC represents complex numbers Z1, Z2, Z1 plus Z2, Z1 plus Z2. Then the diagram OABC is, if suppose it is considered O origin, A point, B point, C point. Here OA equals to, it is considered a vector, it is Z1. Next to it is Z2, it is another vector, therefore it is Z1 plus Z2, Z1 plus Z2 resultant of these two vectors. Now join it, it is C. OACB, B equals to OB equals to, it is given Z2, it is also Z2. Therefore the sides are parallel, then OABC, it is a parallelogram. Option A. Next, the area of the triangle with vertices Z, IZ, Z plus IZ is 50, then mod Z equals to, the area of the triangle equals to 50 square units, then required mod Z. Now first let Z equals to x plus iy, or in order pair x comma y. Next IZ equals to I of x plus iy multiply with I, here I square equals to minus 1, means minus y plus ix, I square equals to minus 1 into y, minus y plus ix, or order pair minus y comma x. Next to z plus iz equals to, add these two, how much you get? X minus y plus I of x plus y, or in order pair x minus y comma x plus y. Okay. Now required area of the triangle with the three vertices given, area equals to half into mod of x comma y minus y x minus y x plus y. Repeat first point x comma y in 2D area of the triangle in 2-dimensional geometry. Now that equals to half into x square minus half minus plus y square, x square plus y square. Next to multiply it, minus xy minus y square minus of these values, minus x square minus of minus plus xy, minus of minus plus xy. Next to multiply these two, plus xy minus y square minus of this value, minus x square minus xy, area equals to, that equals to half into, simplify, see it here, minus xy plus xy cancel, minus xy plus xy cancel. Next to plus x square minus x square cancel, plus y square minus y square cancel, remaining values minus x square minus y square, or that equals to half into mod of x square plus y square, because modulus always positive quantity. Now it is nothing but half into mod z square, mod z whole square, because mod z equals to square root of x square plus y square. Now means always the area of the triangle, it is the formula actually. Area of the triangle formed by z, iz, z plus iz is half into mod z square. Now here given half into mod z square, that equals to 50. Area of the triangle equals to given 50. Mod z square equals to 100. Therefore required mod z equals to 10, because always mod z 10 positive, then take only plus sign, not plus or minus sign, not plus or minus. Now option is C. Next, Z1 and Z2 are purely real. Now let Z1 equals to x1 plus iy1, but it is purely real. Imaginary part equals to 0, means only x1. Similarly Z2 equals to x2. Now what is Z1 bar equals to? Here actually Z1 bar, Z2 bar. Z1 bar equals to same x1, because imaginary part 0. Z2 bar is also x2. Now sides, opposite sides are equal, then it form a parallelogram. Compulsory it is a parallelogram. Next 13. If imaginary part of 43 question, imaginary part of z2 square equals to 1, the locus of z, it is a parabola, hyperbola, rectangular hyperbola, ellipse. Now first let z equals to x plus iy, x plus iy. Now z square equals to x plus iy whole square, x plus iy whole square. Now that equals to we get x square plus iy whole square plus 2xyi, or that equals to x square minus y square plus 2xyi, 2xyi. Okay, z square equals to. Now here real part is x square minus y square, imaginary part is 2xy. Now imaginary part of z square, imaginary part nothing but 2xy. 2xy equals to 1, 2xy equals to 1. Now this equation represents a rectangular hyperbola. Rectangular hyperbola. Now next, it's option C, third option is correct. Next 44, mod of z square minus 1 equals to mod z whole square plus 1, then z lies on. Now first let z equals to x plus iy, z equals to x plus iy. For implies what is z square equals to? Now a plus b whole square, we get x square minus y square plus 2xyi. Now mod of z square minus 1, x square minus y square minus 1 plus 2xyi equals to mod z square equals to x square plus y square, because mod z equals to square root of x square plus y square, its whole square equals to x square plus y square plus 1. Now what is left side magnitude of this one? Square root of real part square, x square minus y square minus 1 whole square plus 4x square y square, or 2xy whole square, that equals to x square plus y square plus 1. Now squaring on both sides, left side square and root get cancel. After that a minus b minus c whole square, x to the power of 4 plus y to the power of 4 plus 1 minus 2x square y square plus 2y square minus 2x square plus 4x square y square equals to right side also square on both sides, x to the power of 4 plus y to the power of 4 plus 1 plus 2x square y square plus 2x square plus 2y square we get. Now both sides x to the power of 4 y to the power of 4 get cancel and 1 also cancel. Next to 2y square cancel. What are the remaining terms? Here minus 2x square y square plus 4x square y square, 2x square y square. Next to minus 2x square in left side equals to right side remaining values 2x square y square plus 2x square. Now 2x square y square also cancel, take complete one side, 4x square equals to 0 for implies x equals to 0. X equals to 0 nothing but imaginary axis or y axis. Option D is correct answer. Next, the locus of z satisfying the inequality z plus 2i by 2z plus I mod less than 1, where here not x equals to, it is z equals to x plus iy, always complex number z equals to x plus iy. Now mod of z1 by z2, mod of z1 by z2 equals to mod z1 by mod z2, mod z1 by mod z2. Now it is nothing but mod of, but z equals to x plus iy given, x plus iy plus 2i by 2 of z x plus iy plus I less than 1. Now numerator can be written as mod of x plus, in iy and 2y I take common y plus 2 of I by, in denominator 2x plus 2iy plus I take common, we get 2y plus 1 of I, it is less than 1. But what is modulus of the complex number? Square root of real part square plus square root of imaginary part square. Now that equals to, here real part is x in numerator, square root of x square plus y plus 2 whole square, y plus 2 whole square by, in denominator what is its modulus? Square root of 2x whole square plus 2y plus 1 whole square, real part square plus imaginary part square under root, it is less than 1. Now cross multiply and squaring on both sides, we get x square plus y plus 2 whole square, it is less than 4x square plus 4y square plus 4y plus 1. Now x square plus y square plus 4 plus 4y less than 3x square, 4x square, 4x square plus 4y square plus 4y plus 1. Now 4y cancel on both sides, these terms take right side. Now we get 0 less than 3x square plus 3y square (1 minus 4 minus 3), or 0 less than, now 3 take common, x square plus y square minus 1, or for implies x square plus y square minus 1 greater than 0, or x square plus y square greater than 1. Now option C is correct answer. Next, 16th is purely imaginary, then mod z equals to 1, so on. Okay. Z minus 1 by z plus 1. It is purely imaginary, then require given options. First, let z equals to complex number z equals to x plus iy equals to z equals to. Now what is numerator we get? X plus iy minus 1 by x plus iy plus 1, that equals to x minus 1 plus iy by x plus 1 plus iy. Now the rationalizing factor or conjugate of denominator multiplied and divided, x plus 1 minus iy by x plus 1 minus iy. How much you get numerator? X minus 1 into x plus 1, x minus 1 into x plus 1, x minus 1 into minus 5, minus of x minus 1 into y, I. Next iy plus I y into x plus 1 minus I into I square minus 1, minus of minus plus y square by denominator a minus a plus b into a minus b, a square minus b square, x plus 1 whole square minus I square y square, but I square equals to minus 1, minus of minus plus y square. Now that equals to here x minus 1 into x plus 1, x square minus 1, a minus b into a plus b, a square minus b square. Next plus y square by x plus 1 whole square plus y square plus I into, in remaining two terms I take common, I of y of x plus 1 minus y of x minus 1 by x plus 1 whole square plus y square. Now in problem given it is purely imaginary, then real part must be equals to 0. Real part must be equals to 0. Now what is real part? X square plus y square minus 1 by denominator x plus 1 whole square plus y square. It is equals to 0. Cross multiply, then x square plus y square equals to, we get 1. But it is nothing but mod z square. Mod of z square equals to 1.